Hi, my name is Nastara Nadeli. I am a learning member of the cohort 6 of Data Science and Machine Learning Certificate at Data Science Institute, University of Toronto. I am going to walk quickly through the projects that we did as a capstone project for the machine learning certificate. The goal of this project was to develop a machine learning model to predict the sales performance based on factors like order date, shipping mode, customer segment, product category. And the business value of this kind of models is to understand the key driver of the sales that can help business to make more data-informed decisions about their strategy for both efficiency and profitability of their sales. In this project, I used the Superstore sales database from Kaggle. This is a database from 2015 to 2019, over 9,000 sales transactions. And it has some features, 21 features, distinct values as order timing, shipping mode, customer segment, product category, discount level, sales revenue, and a profit. First, I went through the data, cleaning data, and dropping the rows like that they have missing values in any column, converting the date and the strings to categorical column, dropping the duplicated row, and do the one-hot encode for categorical features like ship mode, segment, region, category, subcategory. And after that, I did some feature engineering I added one calculated feature as the days between the order date and ship date, and also drop the identifiers like text fields like row ID, order ID, customer names that perhaps are not very valuable for the model. After that, I did some exploratory data analysis just by looking at the data. Some of the interesting facts coming out of this was that, for example, copiers, machines, and table and chairs and bookcases are the highest average sale by category. On the other side, the average profit by subcategory, the highest one is for the copier. Machines actually have much less actually profitability, and categories like tables and bookcases, they're actually money losers. They don't have any profitability at all. Another interesting fact about this EDA was that home office segment has both higher sales and higher profit for this specific superstore. And also the shipping mode, like same-day shipping versus a standard versus the, first class shipping, they actually didn't show any significant impact on the sales. For the modeling approach, the target of the model was sales. And for the model, I trained it based on the linear regression and random forest. And random forest significantly outperformed the linear regression. I also did the hyperparameter optimizations, and after that, the model achieved the R-square of almost 83, 0.83 on the training data, and 0.6 almost on the test data, which shows that the model has a good generalization. The most important finding of this was that on the top features importance based on the random forest model, profit is the most important predictor of the sales. And other factors such as, for example, discount, they have minimal impact on sales, less than 3% of them. And copier led in the both sales and profit, and same as what was in the EDA, tables and bookcases have negative profit margin. The shipping delay also doesn't have any significant effect on the sales. Show that customers are really tolerant about the date of the ship if the expectations is set right. Throughout our project, team project actually, each team member did their own actually model development. Then we compared these models together. So my model compared to one of my teammates' model that had the best actually performance. My teammates achieved higher predictive accuracy, and it had 32% better in R-square and a lower RMSE on the test data. We both use this feature engineering, and also we both did the hyperparameter tuning. The biggest difference between my model and my teammate's model was that he had more features in his feature engineering, like profit per unit, discount to quantity ratio, or customer per category average. Despite the difference between the model performance, both of our models predicted that profit is by far the most important feature, and discounts to quantity or discount, either way, does not have any significant impact on sales, which basically shows the robustness of the model and the insight that we can draw from it. So at the end, the business strategy that we can recommend is that focusing on the high margin products that have more profitability, and perhaps reducing unnecessary discounts to other products can help actually improving the sales performance and focusing the strategy on what matters. For the next step of this project, one thing that comes in my mind is that having more context about the data is very important. Profit its own, as it is in this raw data, is a calculated value which we don't know how is it calculated. For example, is it just the cost of goods sold, or does it include operational costs or inventory costs? These differences can actually help a little bit more explaining about the impact of the discount, and maybe discount doesn't have impact on sales but can have impact on the operation costs or inventory costs. Some other factors that can help the predictive power of the model is that if we integrate external data like marketing activity, competitor pricing, economic indicator, add better feature engineering like exploring the performance of variation across different customer segments or product category, and incorporating some time-based pattern like seasonality or trend scan. Also, advanced techniques like gradient boosting or XGBoost can capture maybe more complex relationship in the data. We can also simplify the model by removing less important features to reduce the overfitting, and we can also add ability to input new data to retrain the model based on this new data to capture the change in the business environment. So overall, about the team project, what I learned was that it would have been much better if from the get-go we will set up some ground rule, like how we are going to name our variables in our models, or we would actually start by first doing a data cleaning, and then everybody in the team use the same clean data set. This way, at the end, we could combine the different models under the experiment in the same repo without actually overwriting anything, and then have a good comparison side by side about that, how the models are different from each other and what is their strength. What are the other challenges that we had as a team? Well, everybody, like real life, had lots of other competing priorities, and this actually, despite that, we did a good coordination to eventually put this stuff together, compare our models, and come with the best result. Again, I think that we could have saved some more time if we would start a little more focused at the beginning, and then save ourselves a little bit more time. And if we had time, well, adding external data source, as I mentioned, and the ability to actually input more recent data to change how it can actually, to see if it can change the model result, would have been really good addition. And a strength that I brought to the team, well, basically, I think at the beginning we needed to define a strategy that how we're going to approach this assignment, and what would be the best way to go through it, beyond just just divide and conquer and defining the task. So since we had a very time crunch, actually, So we had to choose in a very short time that what question we want to answer and how do we want to tackle the team project, and then at the end also how we're gonna actually combine all the results. So I believe that I did a good contribution on that time. And I want to also thank the SI team at Data Science Institute. It was a great learning experience. Thanks all.